Hey guys, welcome to another math video. For this one, I'll be talking about inequalities with two variables. So, this is what we'll be doing. Alright, so let's get started here. So, what we're going to do first is we're going to place the inequality into a version of the slope-intercept form. And I say version because the slope-intercept form normally is for equations, and in this case we're dealing with inequalities. So it's going to look kind of like that form, except instead of an equal sign we're going to have either less than or equal to, greater than or equal to symbol. So we plot it normally like we would on the Cartesian plane, using the y-intercept and the slope. The main difference is when we actually connect the dots is when we have these symbols, we're going to use a dashed line, whereas if we have these symbols here, we need a solid line. Then the last thing we need to do, because this is an inequality and not an equation, is we need to shade. And there's two ways we can do it. So one way is to select a point that's on the graph that's not on your line. You're going to substitute that into your original inequality and then simplify it. And if it comes out to a true statement, you'll shade where the area where that point was that you used, and if it's false, you shade on the opposite side of the line. Okay. The other method is to use the inequality symbol to shade. So we're putting them into a form of the slope-intercept form. So if your inequality has something like this, you're going to shade above the line, and if your inequality has something like y is less than or equal to, you're going to shade below the line. And that'll make a lot more sense once we dive into the examples. So let's go ahead and get into it. So all this, I know it's confusing right now, but let's do the example, you can see what I mean. So let's graph this. So the easiest way is going to be to turn it into a form of the slope-intercept form. Okay, so that's what we're going to do is we're going to isolate y on one side, the inequality symbol. So I'm going to move the 3x here by adding it to both sides. Get this. And then I'll divide everything by 2 to solve for y, because we only want y and not 2y. So everything is divided by 2. Okay, now we need to find a test point to use. And we're going to substitute that into the original inequality. So I'm pretty sure this graph doesn't go through 0, 0. So we can use that as a test point. It's a pretty good one. You can use that for most inequalities as a test point. So what we'll do is we'll substitute this into the original inequality, like so. We'll simplify. And this is a true statement. 0 is less than or equal to 6. So we'll shade this graph where I got the point 0, 0. So let's make the graph and shade it. So here's the graph. You would use this form here to create the graph of the line. So y-intercept is positive 3. You would go up 3 and over 2 from the slope here. Since this is a symbol here, it's equal to. So we said when the symbol is less than or equal to or greater than or equal to, we use a solid line. That's why this graph has a solid line. And we use the test point 0, 0. 0, 0 is not on this line, so that works. And when we simplified it here, we came out to a true statement at 0, 0. So you see all this here is shaded in, meaning this whole area here is part of our solution. Okay, now let's try another one. So we're going to graph this inequality, starting with 3x plus 6y is less than 24. So again, you want to isolate your y variable. So we're going to move the 3x to the opposite side of the inequality symbol by subtracting it. So this is what we get here. And then we'll solve for y. So I'll divide everything by 6. And I get this. So I just simplified the coefficient for x there. Okay, so let's take a look at the graph and we'll break this down. Okay, so using the slope-intercept form here, my y-intercept is 4. And be careful here because the scale is different. Each of these marks here is 2. Okay, so 4 is here. And then I'm going to use my slope, so I'm going to go down 1 and then over 2. Okay, so just be careful of the scale. Okay, so now so now the type of line we use is based on the symbol we have here. So this is a less than symbol. So that's why we have a dashed line here. So if you have a less than or greater than symbol, dashed line, less than or equal to, greater than or equal to, solid line, like in the previous example. Now we need to see where we're going to shade. So since we have it in this form, slope-intercept, we have a y is less than. So remember on the steps, the slide where we had the steps, if you have y is less than or y is less than or equal to, you're going to shade below the graph. So every graph of a line has a above and a below. So for this one, this area here is above the graph, and this area here is below the graph. So since we have y is less than, we're going to shade below the graph. That's why this area here is shaded in. Okay, and that's a much quicker way than using the test point method. It's a shortcut. Definitely use it with caution, because you want to have your inequality set up in this form here rather than the opposite way, because it's going to be more confusing the opposite way. Alright? Okay, so basically we did all these things. I hope it wasn't too confusing. If you want to re-watch it, go ahead and go back to those examples or to any part that you need to hear more on again. If you have any questions, leave them down in the comments and I'll try to get back to you as soon as I can, hopefully pretty quickly. Thanks for tuning in, and I'll catch you next time.